to 0. That is, x is not equal to a. F of x minus L absolute value means less than epsilon. Equivalent saying that f of x is going to be L minus epsilon and L plus epsilon interval. So if epsilon greater than 0, any positive number, we can choose delta. By the way, delta depends on a given value of epsilon, such that x lies in the open interval a minus delta a plus delta not equal to a. F of x will be in the interval L minus epsilon L plus epsilon. Now, geometric interpretation of limits can be given graphically. So epsilon greater than 0 is given. Draw horizontal lines y equals L plus epsilon, y equals L minus epsilon. The portion of the graph should be between those two lines. For this portion, f of x is inside of the interval L minus epsilon, L plus epsilon. Then you can go from here down to see how close x should be to a. Now, see the graphs. First one, f of x is in here. L plus epsilon, L minus epsilon. Epsilon, any given number. Now, when you're choosing, you choose the smallest delta. See, if you look at the graph, it's here to here, but this distance is more than the other one. So basically, you have delta 1, delta 2. So we choose minimum of delta 1, delta 2. Minimum will work for both of them. So if you choose delta 2, which is minimum in this case, x is in the interval a minus delta a plus delta. So our delta equals to minimum of those two. So if you choose x's from here, then corresponding f of x is, see, if I choose x here, go up, that's your f of x. Will be in the interval L minus epsilon, L plus epsilon. So another value you can choose here, corresponding f of x is here. Now, if epsilon changes, becomes smaller, then delta also becomes smaller. So for every epsilon, we can find delta such that if x is chosen from the interval a minus delta, a plus delta, then f of x would be L minus epsilon, L plus epsilon interval, in that interval. Okay, any questions before to continue?
Can you give me an example with this
Yeah,
problem?
we're
Because
going to do it, yeah,
okay.
definitely. Steven. Okay, so before to continue, let's go to the here 1.7. Now let's look at the number 2. Use the given graph of f to find the number delta such that if 0 is less than x minus 3 less than delta, then f of x minus 2 less than 0.5. See, epsilon is given to you. So in this case, epsilon is given to us 0.5. So that's why you have L plus L is 2. So the limit approaches to 2. L plus epsilon is 2.5. L minus epsilon is 1.5. Now x approaches to 3. A equals to 3. So we have our x approaching to 3 from left and right. Now look at the graph. See, it's from 1.5 horizontally you hit the graph. So the portion of the graph is between 2.6 and 3.8. Now you have two deltas. This is delta 1, you have delta 2, delta 1, delta 2. Delta 1 equals absolute value 3 minus 2.6 is 0.4. Delta 2 equals 3.8 minus 3, which is 0.8. Now use the given graph, find the number delta such that this one works for us. For us, delta should be minimum of delta 1 and delta 2, which is minimum of 0.4, 0.8, so we choose 0.4. So delta equals 0.4. 4 epsilon equals 0.5. Now, if it's 0.4, you get 3.4, so this one definitely will be inside. So that's fine. But 0.8 we cannot choose because 0.8 to the left becomes 2.2, which is going to be f of x will be outside of the interval. That's why we choose the smallest one. Smallest one works for both of them. Now this one shows if the graph you have it, you wanna, let's assume you wanna have accuracy up to 0.5. So your f of x should be close to less than distance like a 0.5, epsilon 0.5. That means x values should vary between 2.6 and 3.4. It's 0.4 to the right, 0.4 to the left. For those values inside, if you choose x's, let's say 3.2, 3.1, 2.7, 2.8, anything you choose, f of x will be closer to 2, less than 0.5 distance. So any question on this one? Now let's do number 4. Okay, read the problem. So use the given graph of f of x equals x squared to find the number delta such that if x minus 1 less than delta, then x squared minus 1 is less than 1 over 2. Now again, epsilon is given to you. Now remember those examples because those are just practice examples. In general, we're going to find the relation between epsilon and delta. For any epsilon, there is going to be delta that, if the limit exists, this definition will be true. Now, x is less than, x minus 1 is less than delta, means x is in the interval from 1 minus delta, 1 plus delta. And for those values, we need to have f of x between 0.5 and 1.5. Any ideas how can we find those deltas? Look at the graph. See, there are question marks. We need to find those corresponding numbers to be able to determine deltas. See, we have delta 1, we have delta 2. And then we can choose the smallest one. But first, in order to find delta 1 and delta 2, I need to find the numbers corresponding to the question marks. How do we find those? So let's say this is x1, this is x2. How do I find those numbers? Now, x1 squared is 0.5. So x1, we choose positive, square root 0.5, which is approximately equals. Okay, square root 0.5 equals 0.707. Yeah, it's almost 0.7. Let's see, 0.71, for example. Now, delta 1 is distance between x1 minus 0.71, which equals, so 1 minus 0.71 would be 0.29. Now, x2 squared equals 1.5. So x2 is square root 1.5, which is approximately 1.225. Now, delta 2 can be used 1.225 minus 1, which is 0.225 or 0.23. 0.23. Now, which one is the smallest one? So delta should be minimum of delta 1 and delta 2, which is minimum of 0.29 and 0.23. Would be 0.23. So we can choose our delta to be 0.20. If it's 0.23, this one would be shorter, this way, and it's x1 minus 0.23, x1 plus 0.23. So will work for us. Okay, any question on this one? Okay, read problem number 14. So, given that limit of 5x minus 7 as x approaches 2 equals 3. By the way, it's a direct substitution. You can directly substitute 2. 2 times 5 is 10. 10 minus 7 is 3. So it's 3, correct. Illustrate by finding values of delta that correspond to the epsilon equals 0.1, epsilon equals 0.05, and epsilon equals 0.01. Now let's go to the whiteboard. So given limit, this is number 14. 5x minus 7 equals 3 as x approaches 2. Finding delta for, let's do epsilon equals 0.1, delta equals question mark, epsilon equals 0.05, delta equals question mark. So approaches to 2, it's 3. So let's graph it. So let's do this way. X is 1, we have negative 2. X is 2, we have 3. This is what we have. This is the graph. So approaching 2 approaches to 3. So those are the points. Now 0.1, so I need to have three. L minus epsilon would be 3 minus 0.1 is 2.9. L plus epsilon equals 3 plus 0.1, which is 3.1. So if I assume 3.1 somewhere here goes here, so corresponding value here, and this is the other one goes here. So I have 2.9, 3.1. So I need to find x1, x2 to be able to find deltas. Now, f of x, 5x minus 7, f of x1. So this is 5x1 minus, must be equal to 2.9. So 5 times x1 is 9.9. x1 equals, so 9.9 divided 5. So this is 1.98. So So delta 1 is 2 minus 1.98 equals 0.02. Now, 5x2 minus 7 should be 3.1. So 5x2 is 10.1. x2 equals divided 5 equals 2.02. So delta 2 equals 2.02 minus 2, which is 0.02. So delta equals minimum of delta 1, delta 2, which is 0.02. Now, so for the first epsilon, I found it. It's 0.02. Find for the second one. If epsilon is 0.05, so L minus epsilon is 3 minus 0.05, which equals 2.95. L plus epsilon equals 3 plus 0.05 would be 3.05. Now find delta 1 and delta 2 in this case and then choose the smallest one. So you have 5 times x1 minus 7 is 2.95. So 5x1 equals 9 point. So this is 95. So x1 equals 1.99. So delta 1 equals 2 minus 1.99, which equals 0.01. Now 5x2 minus 7 is 3.05. So 5x2 equals 10.05. x2 equals 2.01. So delta 2 is 2.01 minus 2, 0.01. Now delta equals minimum of delta 1, delta 2, which is 0.01. Now, if you continue this way, we can notice it. Epsilon is 0.1, delta is 0.02. So let's do this way. 0.1 divided 0.02. It's 1/5 of the epsilon. Epsilon is 0.05. Delta is 0.041. 1/5 of the epsilon. Any question regarding those calculations? Now, the next problem will be proofs using the epsilon delta definition. Now, on this example, I'll do so you can see it. Now, let me erase this calculation part. And then demonstrate how we do by definition. Okay. Now, limit in general given to us of 5x minus 7 equals 3 as x approaches 2. So first step, you can use given for any, for every, doesn't make difference. For any epsilon greater than 0, there is a delta greater than 0 such that if 0 is less than x minus 2 less than delta, then absolute value 5x minus 7 minus 3 is less than epsilon. This is what definition says. If the limit of function, which is in this case f of x, is 5x minus 7 equals to L is 3, such that x approaches to A is 2, then for every epsilon, we should be able to find delta such that if 0 is less than x minus 2 less than delta, then this 5x minus 7 minus 3 is less than epsilon. So we start from this. 5x minus 7 minus 3 equals 5x minus 10 equals 5 times x minus 2 equals 5 is positive, x minus 2. Now, x minus 2, absolute value of x minus 2 is less than delta. So this is less than 5 delta. But we wanted this one to be less than epsilon. So 5 delta equals epsilon. Delta should be 1 over 5 epsilon. This equation shows the relation between delta and epsilon. If epsilon is given, 1/5 of the epsilon should work. See, our deltas are both of them 1/5 of the epsilon. There is second part. So this is first part. There is a second part that we need to show that this delta works. So if delta equals 1 over 5 epsilon, and 0 is less than x minus 2 less than delta, then this expression 5x minus 7 minus 3 equals 5x minus 10 equals 5 times x minus 2 less than 5 times delta, but this is 5 times 1 over 5 epsilon, so we get epsilon. So absolute value 5x minus 7 minus 3 is less than epsilon, which implies by epsilon delta definition, limit of 5x minus 7 equals 3 as x approaches 2. So we finished. This is called proving using the epsilon delta definition. Now, any question? This second part we did wasn't required for this problem, but because we had like a numerical value, so you can see how it works. See, for example, there was epsilon 0.01. Then the corresponding delta would be what? Divide by 5. So 0.01 divided 5 would be 0.002. You can do algebra, but as long as you have delta equals 1 over 5 epsilon relation, then you can use the relation and finish it. Now, let's do problems involving definition because that's what you're going to have it on your exam. Just pay attention the steps I'm doing, the way I'm writing, because you can change the words, but you have to keep the meaning. So the next set of the problems says, prove the statement using epsilon delta definition of a limit and illustrate with the diagram. Now, diagram part is not required. Don't worry about that. But like a definition, we're going to use. Okay, let's do number 16. Limit 2x minus 5 equals 3 as x approaches 4. See, 4 times 2 is 8. 8 minus 5 is 3. It's correct. Now, step 1, or part 1. For any or every or given, doesn't make difference. Epsilon positive number, there is a positive delta such that if 0 is less than x minus 4 less than delta, then absolute value 2x minus 5 minus 3 less than epsilon. So this is just based on a definition for almost all those type of problems, we start this way. Now you start working with 2x minus 5 minus 3 to find the relation between delta and epsilon. So this should be less than epsilon, equals 2x minus 8, 2 times x minus 4, so it's 2 times x minus 4. This one is less than 2 delta because x minus 4 is less than delta. So, but it should be less than epsilon. We choose 2 delta equals to epsilon. Delta is 1 over 2 epsilon. This is the first and the important part. So any question on this one? No. Now step 2, it's just a writing, but for given epsilon,
We have a question now.
yeah,
Where
and
did
yeah, so
where did the 2 delta come from?
x minus 4, you have it. Say it says if 0 is less than x minus 4 less than delta. So x minus 4 is less than delta. So 2 times x minus 4 will be less than 2 delta. Here. Delta equals 1 over 2 epsilon, and 0 is less than x minus 4 less than delta. We have absolute value 2x minus 5 minus 3, which equals 2x minus 8, which equals 2 times x minus 4, which is less than 2 delta, which equals 1 over 2 epsilon equals epsilon. So absolute value 2x minus 5 minus 3 less than epsilon implies by epsilon delta definition limit of 2x minus 5 equals 3 as x approaches to 4. So for given epsilon, delta equals 1 over 2 epsilon, and actually here we can use if. 1 over 2 epsilon and 0 is less than x minus 4 less than delta, then we're showing that it works for us. It becomes less than epsilon. Now leave this one on a board, even though you have it. Try 18, write the proof. So if you substitute, you get negative 6 plus 5 is negative 1. So A is negative 2, L is negative 1, f of x is 3x plus 5. So try write the first step first, and then we'll go to the second step. So for any epsilon, or for given epsilon, or for every epsilon, all three words can be used. There is a delta such that so write the first sentence. So this part should be changed. This part should be changed. Definitely this one will be changed. Let's see how are we going to choose our delta in this case. So again, for any epsilon, there is a delta. 0 less than absolute value x minus, so this is changed. So you have limit so x minus negative 2 less than delta, then 3x plus 5 minus negative 1 is less than epsilon. Now notice that this is the same as x plus 2 is less than epsilon. Now start from 3x plus 5 minus negative 1 equals, and find constant multiple of x plus 2, which is the same as x minus negative 2. So it's 3x plus 5 plus 1. 3x plus 6, 3 times x plus 2. This is 3 times x plus 2. So it's the same as 3 times x minus negative 2. This should be less than 3 delta. Now, if you make your 3 delta equals epsilon, delta is 1/3 epsilon. Now let's write the second part. So for epsilon greater than 0, if delta is 1/3 of epsilon, and here you have x minus negative 2 is less than delta, we have this part should be, okay, let's, delta equals 1 over 3 epsilon and 0 is less than that. We have absolute value 3x plus 5 minus negative 1 equals. Now we want to show that this one is less than epsilon for those choices. So you get 3x plus 6, 3 times x plus 2, this is less than 3 delta. But delta is 1/3 epsilon equals epsilon. So left hand side less than epsilon implies by epsilon delta definition limit of 3x plus 5 is negative 1 as x approaches negative 2. So any question? Now try one more and then the rest will continue tomorrow. So let me erase this. Little bit switched. Let's say number 17. So L is 13. A is negative 3. F of x is 1 minus 4x. Write the epsilon delta proof for this one. So, Grigorian, Samuel, Fabian Gutierrez, Sarkisian, Caro Daniel, do this. Let me check something. tangent level. Okay, let's check your first step. For any or every epsilon greater than 0, there is a delta greater than 0 such that if 0 is less than absolute value x minus negative 3 less than delta, then absolute value 1 minus 4x minus 13 is less than epsilon. This is the first step. Now, a few things. Notice 0 is less than, this is x plus 3 less than delta. This one you have 1 minus 4x minus 13 less than epsilon. Now start. 1 minus 4x minus 13 equals negative 4x minus 12 negative 4x plus 3 absolute value negative 4 absolute value x plus 3. This is 4x plus 3, which is less than 4 delta. So we choose for delta to be epsilon. Delta equals 1 over 4 epsilon. So we got the important part. Delta and epsilon are related by this equation. Now second part. Here 1, this is 2. Right now second part. So for given epsilon, if delta equals 1/4 epsilon and 0 is less than x minus negative 3, less than delta, we get or we have absolute value equals. So this is negative 4x minus 12, 4 times x plus 3, 4 times x minus negative 3, less than 4 delta, which is 4 times 1 over 4 epsilon, equals epsilon. So 1 minus 4x minus 13 less than epsilon implies by epsilon delta definition, limit of 1 minus 4x is 13 as x approaches negative 3. Now, this is one type of problems. The other type that will be on your exam, we'll discuss tomorrow. Now, any questions so far?
So we don't need to do the second part, or we do, or is it only on certain problems?
No.
Or is
This
the
is one type of problem. You're gonna have like more complicated ones tomorrow. So that requires more steps. This is just the basic one, linear. So strictly you get the relation between delta and epsilon. Tomorrow will be quadratic, and I'll do like something additional for you. But like one type is this type will be on your exam. The other one, I'll talk about it tomorrow. Okay, any questions? Now, if you have a question, you can ask me. No questions. See you tomorrow. If
Professor,
yeah,
I was trying to solve a previous problem, but I didn't learn how to solve the other steps because you erased it.
for which one? Previous one?
Yeah, it's a previous one. It's the one that you did just before this one.
Yeah,
It was finding delta.
right. All of them are like that. The one that
No,
3 plus 5?
I think it was number 14. Or I don't remember. It was like before.
14 is not the right previous one. It's like a few steps before that. It's okay. I'll do it again if you want it.
No. It's just, isn't it your notes? It's like,
No, I'm doing this and I'm not saving them.
oh, you're not saving them?
No, you can do like a screenshot or something if you say like you don't, and keep it, but I don't save them.
It's because I have a screenshot of it, but it's not complete.
Okay, let's finish. If nobody else has it, share your screen. I'll show you how to complete it.
But let me take a screenshot of this one because this one's complicated.
Okay.
Okay, there you go.
Any other one? Needs this one? Or? Okay, so if you don't have questions, see you tomorrow. If you have question, 11 o'clock, I'll open the office hours. If you have any question, you can ask me. Now, if you want to share your screen, you can share your screen. I'll just, on your screen, I'll complete it or I'll tell you what to do. Right? Yeah.
I think it's just, yeah, so you didn't save it, so that's the problem.
It's okay. Just get the problem at least. Like we can talk about it.
It's just one part of the problem. It isn't the whole problem.
Okay.
It's number, do you know